Today's lesson is focused on adding integers with different signs. So yesterday we focused on things with the same signs, and today we're going to be focusing on different signs. So to begin, we have a warm-up of yesterday's material. Remember, if they have the same sign, add the numbers, keep the sign. Pause the video, complete the warm-up, come back and check your answers. Looking at our answers, because we were adding two negative numbers in each problem, all of our answers ended up being negative. Number 1 was negative 18, number 2, negative 7, number 3, negative 8, and number 4 was negative 12. To begin today's lesson, we have some key ideas about what we're going to be focusing on. Our first key idea, so in our first box, we're adding integers with different signs. And what that says is that we subtract the lesser value from the greater value. And we're thinking in terms of absolute value. So if we look at this first example down here, the absolute value of 8 is 8. The absolute value of negative 10 is 10. So what we're going to do is we're going to take 10 minus 8, which equals 2. But then you use the sign of the integer with the greater absolute value. This was our greater one. We used the sign, which was negative. Our answer is negative 2. We have another example, negative 13 plus 17. We subtract 17 minus 13, which is 4. 17 is bigger, it's positive. Our answer is a positive 4. That is adding integers with different signs. We also have a second thing to think about today, and it's called the additive inverse property. What this property is if you take the sum of an integer and its additive inverse, or its opposite, we know the word opposite, it should equal 0. And we talked about this yesterday actually. 6 plus negative 6, so an integer plus its opposite equals 0. Negative 25 plus 25, integer and its opposite equals 0. And that holds true every time. So here they have it in algebra terms. Any number, a, plus its opposite, which is the opposite of a, when you add them together, it will always equal 0. And that holds true because of our additive inverse property, which we're going to be using a lot this year as we progress. Now, if we'll recall, our key for subtracting integers with different signs is to subtract our numbers, bigger goes on top, and keep the sign of the bigger number. So we first, for part A, we are going to find 5 plus negative 10. Now, think about this. We have absolute value of 5, which is 5. Absolute value of negative 10, which is 10. We subtract the bigger from the smaller. So we're going to take 10 minus 5, which is 5. And then we take the sign from the bigger number. 10 is bigger than 5. We're going to take its sign. It's a negative 10. So our answer should be negative 5. Now, if we would look at it on a number line, first you start at 5. We'll put a dot at 5. And then we're adding negative 10. Remember, adding a negative, we go down our line 10 spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We end up at negative 5. We did our math correct. Our next problem is negative 3 plus 7. 7's bigger, so we take 7 minus 3, which is 4. And because 7's bigger, we use that sign. It's positive. Our answer should be positive 4. We can check it on our number line. We're going to start with a dot at negative 3. And if we add 7, we are going to go up the number line because it's positive. 1, 2, 3, 4, 5, 6, 7. And we did end at 4. And then last but not least, this one actually is a number plus its opposite, negative 12 plus 12. We know because of the additive inverse property, it should equal 0. If we use our rule from above, 12 minus 12 is 0. 0 doesn't have a sign. And we could always check using our number line. Start at negative 12, 11, 12. So we're going to draw it in right there. And then we're going to add 12. Adding a positive, we go up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We end at 0. On your own, I want you to pause the video and try adding these 3 problems. Remember, use the number line if you need to, and look back on the last slide if you want a hint about we subtract the numbers, keep the sign of the bigger number. Looking at our answers, number 4, 11's the bigger number, so we do 11 minus 2, which is 9. 11's positive, positive 9. Number 5, 9 plus negative 10 is negative 1. 10's our bigger number. 10 minus 9 is 1. 10's negative, so we have negative 1. And 16, an opposite plus its inverse equals 0. And last but not least, sometimes you're going to be adding or subtracting integers with story problems. So we have a list over on the side about how much money was withdrawn or deposited into a bank account. And what we have to do is we have to find the sum of those transactions. Remember, sum is adding. So I'm going to take all 4 transactions and write them as a number sentence using addition. My withdrawal was negative 40 because I took money out, plus a deposit, which is putting money in, of 50, plus another deposit of 75, plus a final withdrawal of negative 50. Next, what we want to do is we want to actually figure out what does this equal if we would solve it. Look at 2 numbers at a time. I'm going to start with my first 2, negative 40 plus 50. One's negative, one's positive. Different signs, so I'm going to subtract my numbers. 50 minus 40, which is 10. 50 is my bigger number, it's going to be a positive 10. I'm going to do the same with the next 2. 75 minus 50, which is 25. 75 is my bigger number, so it should be positive also. We're adding these together. 10 plus 25 is 35. So what this is saying is you deposited $35 more than you withdrew, which is what you would like to do in bank accounts.